Again, everyone, and now we're going to look at how to multiply radicals, which would be EE4. Go ahead and get rid of my face here. Okay, multiply radicals. First of all, let's kind of get a look at this. Let's do it with some numbers that we actually know. The general idea of multiplying radicals, before I even do the numbers, it's like this. The square root of A times the square root of B is the same thing as the square root of A times B. That's the general format. Doesn't matter how many of those you multiply, you can put them all under the same radical if all you're doing is multiplying. So now let's look at some that we know. Let's do the square root of 9 times the square root of 16. All right. Well, we already know what those are. So we know that the square root of 9 is 3, and the square root of 16 is 12, or 4, I mean. And if we take 3 times 4, that equals 12. Now let's see if our theory that if we put all this underneath the same radical will work. So I said that the square root of 9 times the square root of 16 is the same thing as the square root of 9 times 16. If you have a calculator, you can use that. I'm just going to use my understanding of numbers. I know that 9 times 10 is 90. And I know that 9 times 6 is 54. So that's going to be 90 plus 50 plus 4. 90 plus 50 is 140. And the 4, so that's 144. So 9 times 16 is 144. So it would be the square root of 144, which if you look that up or you just happen to know, that would be 12. Okay? So as you can see, those are the same number. We'll go ahead and do one more example here. Because sometimes they don't come out that easy. Let's do the square root of 25. We know that's 5. Okay, times the square root of 36. All right, we know that's 5 times 6 is 30. But we're going to put the whole thing under a radical. So we take 25 times 36. And this time we're going to use a calculator. 25 times 36 is 900. And the square root of 900, that would be 30 times 30. So that would be 30. I'm going to check real quick and see if that's right, because we said that's 5 times 6. 5 times 6 is also 30. So we see that that works. All right, and these are perfect squares, so that's a little bit easier. Let's try one without perfect squares. Let's take the square root of, I don't know, let's take the square root of 4 times the square root of 7. Okay, now we know that's going to be 2 times the square root of 7. Let's go ahead and do it like this. We're going to say that's the square root of 4 times 7, which is the square root of 28. Now, if we put this in IXL, it's going to say, oh, something's off from this. It would want us to do this. Want us to do the prime factorization. That's going to be 2 times 14. And that's going to be 2 times 7. All right. And then we remember square roots. We're looking, that means 2 of them come out. So, whoops. So that these 2's right here come out. And so that would be 2, because that's the square root of 4 right there, times the square root of 7, which is what we would have seen up here. Okay? So that would be 2 square roots of 7. And what I'm saying, the way you can kind of check that, the way you can kind of check that is 2 square roots of 7. Oh, things going crazy on me. 2 square roots of 7. I know that this is 2, square root of 4 is 2, and that's 7. So it is 2 square roots of 7. Let's try one where it doesn't come out anything like that. Let's do square root of 3 times, there's that bell, times the square root of 5. That would be the square root of 3 times 5, which would be the square root of 15. And of course, that's broken down into 2 primes, so there it is. That's how you would do that one. Okay, so if you have any questions, just let me know, and we'll see if we can get it figured out. Thank you very much.